በመቀጠል የምናየው the method of Lagrange's multipliers. This is a method that introduces a new variable known as lambda called the Lagrange's multiplier. So the theorem ምንድነው የሚለው, let's say we have two functions which have continuous partial derivatives such that f has an extreme point, let's say a point AB, on the smooth curve g of xy is equal to c. So as you if the gradient of g is different from 0, the main idea of the theory ምንድነው, the gradient of the function is equal to, the function f is equal to lambda times the gradient of the smooth curve g of xy at points ab ማለት ነው። ስለዚህ በዚህ መሰረት ማክሲመም እና ሚኒመም ማግኘት እንችላለን ማለት ነው። and the method of Lagrange's multiplier functions of three variables in a similar manner ነው የሚሰሩት። ስለዚህ በዚህ መሰረት አንድ ሲምፕል የሆነ ኤግዛምፕል እናያለን። ስለዚህ እዚህ ጋር የመጀመሪያ ስቴፓችን ምንድነው? it's finding the constant lambda, Lagrange's multiplier መፈለግ ነው ማለት ነው። ስለዚህ we have three equations እዚህ ጋር, since this is a function of three variables, fx which is equal to del f by del x is equal to 3, fy which is equal to del f by del y equal to -2, and fz which is equal to del f by del z is equal to 1. So we have gx which is equal to del g by del x. እዚህ ጋር ያው እንደምናውቀው g of xy z is equal to c ፎርም ነው መቀመጥ አለበት። ስለዚህ ይሄንን ፈንክሽን ነው ፓርሻሊ ዲፈረንሺየት የምናደርገው ማለት ነው። this is 2x gy is equal to 2y and g with respect to z is equal to 2z. ስለዚህ ኢኩዌሽናችን ፎርም እናደርጋለን። fx is equal to lambda times gx, which means that 3 is equal to lambda times 2x, and similarly ziga -2 is equal to lambda times 2y, then 1 is equal to lambda times 2z ማለት ነው። ስለዚህ በዚህ መሰረት ለላምዳ ሶልቭ እናደርጋለን። ለx ለy እና ለz ሶልቭ እናደርጋለን። in this case x is equal to 3 over 2 lambda, እዚህ ጋር ደግሞ y is equal to -1 over lambda, እዚህ ጋር ደግሞ z is equal to 1 over 2 lambda። ስለዚህ ይሄንን እነዚህ ሶስቱን ኮንስትሬንት ኢኩዌሽኑ ላይ ማለትም g of x y z ላይ ሰብስቲቲዩት በማድረግ ለላምዳ ሶልቭ እናደርጋለን ማለት ነው። this implies that using the constraint equation 3 over 2 lambda the whole square plus -1 over lambda the whole square plus 1 over 2 lambda the whole square is equal to 14. ከዛ ለላምዳ ሶልቭ ስናደርግ this implies that 56 ይሄንን ኢቫሉዌት ስናደርገው lambda square is equal to 14, lambda square is equal to 1 over 4, then lambda becomes plus or minus 1 over 2. ስለዚህ ለፖዚቲቭ 1 over 2 እና ለኔጌቲቭ 1 over 2 we find corresponding values of x. ከዛ በኋላ ማክሲመም እና ሚኒመም ማግኘት እንችላለን ማለት ነው። ስለዚህ let's take the case of lambda is equal to positive 1 over 2. in this case የx value ስንት ይሆናል ማለት ነው? is equal to 3 over 2 lambda is 1 over 2, this is equal to 3. y similarly -1 over 1 over 2 which is equal to -2, and z is equal to 1 over 2 times 1 over 2 which is equal to 1. So when lambda is positive 1 over 2, our point becomes 3 minus 1, sorry, -2 and 1. Because when lambda becomes -1 over 2, it's just the negative of these values. So the point becomes -3, 2 and -1. ስለዚህ at these points functionaችንን evaluate በማድረግ we can find the maximum and the minimum. Since this is positive, this will give us the maximum and this will give us the minimum. So the f of 3 minus 2 1 evaluate ስናደርገው 3 times 3 minus 2 times minus 2 plus 1 ስንት ይመጣል? Final value it's 14, and the minimum value at minus 3 2 minus 1 will be minus 14. This is our final answer.